So, welcome. This is Building Autonomous Agents, Guide to Building AI Agents in .NET with Azure Foundry as the backing resource. Oh, there we go. For you that haven't had the mispleasure of meeting me yet, my name is Andreas Wänqvist. I am a Microsoft MVP in web technologies, go figure. I work for a really cool Swedish company called Voyado. We're one of Sweden's fastest growing SaaS companies, so check us out if you want to do something fun. I also do some open source work in a web framework called Øredev. Anyone heard of it? A couple. Cool. Nice to meet you. Yes, more AI. So, 2025 is said to be the year of the agent. How come? Well, we already have great base models, good intelligence. We learned, and the previous year everyone was talking about RAG, right? Pulling your data into the context, letting the models reasoning over it. We got the function spec from OpenAI, which enabled us to call functions, reach out, do more, and then eventually Anthropic released the MCP protocol in, I think, November last year, and it's everything that we've been hearing about last couple of months. Everyone has an MCP client on the server right now, enabling us to reach out to GitHub, Jira, all those other services that we as developer like. So before we really get going, the question is, what is an agent? How do we define it? What does the standards say? Well, of course, there is no standards. Everyone is competing right now, and people are kind of not sure what's what. But what we can say, at least, is that an agent has intelligence in some kind of form, model. 99% of cases nowadays, we're talking about large language model. Might be a smaller one, might even be a machine learning model. It has some kind of memory. Now, some people says that agents doesn't have to have memory, but I think it's good. Maintaining context in some kind of way, maybe even learning. It has agency, of course. As the name implies, agents has agency. They can do things, finally. We can reach out, touch each other, and other cool things. And it has autonomy to some degree that it runs in the loop. It has a task. It's supposed to do something, and it's not supposed to stop until it's done. Most of you probably tried out coding with AI. Anyone? Yes, people still awake? Lots of you. Okay, so you know that a common problem is, why are you stopping? I didn't say you were done, and you're clearly not done. You haven't fulfilled the task I told you to do. So run in the loop, make sure you're done. Azure Foundry is our new glorious landing space and corner of the Azure portal. Anyone has checked it out? A few of you, yes. Most of you have probably seen the Azure portal though, and you can clearly tell that this isn't like Azure portal-y. This is different because, of course, AI is moving so fast that the teams that are working on this decided to use another framework because they're moving way faster than the Azure portal framework and tools are. So it looks a little bit different, or it looks very different. And it is kind of different, navigation and stuff. But this is where you will find the models, which is the base of everything we do with agents. Eval and tracing, super duper important. Never leave home without it, I was about to say, but it's never put anything LLM based into production without proper eval and tracing. One of the few key takeaways you have to bring from this talk. new service in there called Agent Service. Kind of a ClickOpsy thing where you can set up agents. Can be very nice, of course. Very nice for prototyping, rapid prototyping. You can dry run all your prompts. You can also use them in production if you choose to, which is nice. And you have also a service for storing memory. Memory is kind of a quirky thing with agents or LLM-based any application at all, really. So it's kind of nice to have those there as a service, although it's not maybe what you're going to look for when you do this in production. You can also set up agent-to-agent workflows. I'll show you how to do this in code soon enough. When you go into Foundry, you'll get a long list of things you can do. At the far bottom, I don't know, can you see this text at the very back? Or is this too small for you? Okay. It's easy. You just follow the red arrows, right? So at the bottom it says models, and then you have the blue button which helps you deploy models. And as you can see, I've already pre-deployed a couple here. This is for the demo. We'll hopefully get to later on. A couple of GPT models. And we're going to set these agents up in code. And when you do that, you need a URI, and you need the API key. Or for the kind of agents that we're going to do, and if you try my demos at home, because you'll get access to the code, it's special, only for you. You need to use the URI from the OpenAI. This is tabs. It's kind of hard to see on the screenshot, but you need to press the middle one, right? And get this URI, otherwise it won't work. As usual, red arrow, follow it. So, version of this talk I've held a couple of times before, but it was actually it was about semantic kernel. Anyone heard of that? Few, yes. It was previously the best way to build agents for us C#.NET developers. But out comes Microsoft Agent Framework. It went out in preview now in October. So as you understand, it's fairly recent bit. Not like pre-beta as you do, pre-release, but it's kind of early. Most of the packages I'm using is marked as pre-release. Still good. And it's really the philosophical successor to both semantic kernel and AutoGen. Semantic kernel was what we used when we tried to do more enterprisey apps with tracing and evals and logging and keeping it like standard, secure, like we used or like we want to have our code during weekends. AutoGen was a framework from Microsoft Research, which was focusing on more on agent collaboration and also like implementing new research things. So that was always kind of in flux and moving. Now they married those two into Microsoft Agent Framework. In it, we have support for Azure AI Foundry agents, which you can set up in Foundry. Excuse me. And agent workflow management. We didn't have that in semantic kernel. So that's just creating workflows where parts of the steps are LLM-based inference. Builds on open standards like MCP, agent-to-agent protocol, something that Google released a couple of months ago, I think-ish, like pre-summer. OpenAI stuff, of course, and it's cloud agnostic. So, very nice. I got kind of cut off. But this is the agent types that Microsoft Agent Framework supports. And I don't like this slide at all, because what this implies, if you just squint at it, this means there's too many options and they all look alike, which is kind of bad. We're going to look at this one, Azure AI Foundry model-based agents. So that means we'll spin them up ourselves. We won't have much help, but we like control, right? Because we're developers. I just assume that. You are developers, right? Yeah, people nodding. Those awake are nodding. That's good. So how do we construct an agent? Quite simple. Just instantiate an Azure OpenAI client, and then we give it key and URI to the resources, like I showed you before. Looks like this in code. Is that visible for you in the back? Cool. You're all young, so you got good eyes. That's nice. Yeah. Here you see, key, endpoint. Was the one I pointed at before. This is a helper I've done, but you just send in a string here that denotes the model that you want to use. Since it's just strings, you kind of you skip a character or something or type wrong and everything goes to poo-poo. So that's why I just made a helper for it. You say create an agent, give it a name if you feel like it. Can be good for when you want to trace what's going on. And instructions that basically system prompt, right? So that's your basic agent. Quite simple. Don't you agree? Yes. Here comes the sad part, memory. When you get old, you lose it. When you're using agents, it's a mess. So there is a very simple, we call it agent thread, that is automatically initiated in memory for you if you don't explicitly define it. If you define it, you can reuse it for serial calling, right? That means you will keep the history of what you have chatted or done with the agent in this thread. It's fairly basic, and you can just serialize it and save it to a blob or something if you feel like it. There's also services that take care of it for you. Still very basic. You can implement a custom store, chat message store. There's an abstract class for it. You just implement that, and you have a couple of more things in this, like reduction, for example, because you all heard context, right? Context size. Different models takes different context sizes when you shift data into it. If you let your memory run out of hand, too much just history or whatever, it will perform badly. Worst case, it will just truncate and things will get lost. Reducing the memory is basically, you can choose to either truncate if you want to keep it super simple, or you do something like send it into another agent and say that reduce this to like summarize it, and then you save that. Long-term memory is like really hard, super hard. One of the hard things about building agentic systems, in my opinion, because not only do you need reduction and summarization, but you also often you need some kind of weight on it. It's like, how important are things? If I ask the model, what's the weather today? Super important information. If I'm going out with the dog for a walk in 10 minutes, I want to know if it's raining. But if I ask it the same thing tomorrow, and that information is in the history, how important is yesterday's weather tomorrow? Not that important, right? So this is one of the really hard things about building agentic systems. I'm scaring you before we do the good parts here. I apologize. So, a new thread, super simple. Just create the agent before and get new thread, and then we inject it. when we run the agents. And as you see, if we continue chatting, just send the thread in and the history will be in there, right? Tools. Some of the fun parts. Reaching out into the world is always nice, and when agents were able to do that, well, all of a sudden we can do some proper cool things in our applications with it. Now, functions or methods in C# can be used. Any function can be a tool, no problem. Just AI function factory create and send in the function, and you got one. We use description attributes to tell the LLM what this function is about. So this description is going to be sent into the LLM in the context. Also this for the parameter, right? So these two, also one of the hard things about building agentic systems, because you need good descriptions that don't have much overlap with other tool descriptions for it to be able to know what tool to call properly. And then we send it into the tools array, AI function, factory create, and the weather function we defined. Simple enough, right? We can also use agents that's already created as tools. Then we just call as AI function on the AI agent itself. So here we define an agent that can tell the weather because it's using the nice weather function we had before. And then in another agent, we just send it into the tools array, weather agent as AI function. And then it will use the other AI agent if you ask what the weather is. MCP. Who's heard of MCP? It's good. That's pretty cool. There was few hands that were using this in production, but yet everyone has heard of MCP. Quite amazing times we live in. Talk about reaching out to people. Just cast it to an AI tool and we're off to the races. So this is not important. This is just setting up an MCP client, right? And returning all the tools from it, an array. So up here, there, we get the tools, and then we just spread it, cast it to AI tool, and we're done. Kind of an easy way. So I probably won't have time to run this demo, but this is just using the GitHub tool, and like you can ask it what's the status of my public repositories without being logged in. Super simple. Oh, sorry about that. Another display glitch. There are some tools built into Azure Foundry. So these are a bit more complex, like search, really good. You can access your Azure functions that you have in production already. Very good, very nice, very demure. Browser automation, I haven't tried that. So we've seen the examples on the web, it works so, I think, but could be cool. Code interpreter, really good. Throws up a sandbox and allows you to run Python in it to discern some logic problem the agent might have. Safe, nice, keep it out of your production environment. Don't need to spin up any VMs for that. You also have grounding with Bing Search, really nice. And OpenAI's Deep Search as well. Some of these tools are like gated. Also some of the models, GPT-5, the big one, for example, you have to send in a request to be able to use it for your company because resources are scared. This is one of them as well, but nice if you want to use them. Middleware. How are we doing? Middle of the presentation as well. Perfect timing. Middleware used, everyone who's coded some ASP.NET stuff knows about middleware. Really nice to have, especially for cross-cutting concerns like billing, logging, rate limiting, things like that. agent run middleware and function calling middleware. Then you also have a chat client middleware available for an iChat client, which is kind of not fully an agent, but you can get an iChat client from an agent if you want to, but it doesn't have access to tools, so not as powerful as we like, right? But getting access to the input and output from an agent, being able to look at it before you send it off to a user or whatever, really handy. Also function, you get access to the function context. You can see why it's been called and the result it's returning. Also very good to be able to pick that up, eventually manipulate it if you want to before it's sent into the model. So this is just an agent run middleware. So intercepts before it's run, you have access to messages and thread and everything else, and then you run it, and then you just return the response after you've done handling the response if you want to do that. Function calling middleware, so you have access to the context, you can see name, etc. And then you have access to the result. We just log it to the prompt and then return the result. Use it or inject it using the builder pattern into the agent. Just do as builder and then use your functions or middleware, sorry. Metacognition. Now it's getting hairy. Anyone knows what metacognition is? Metacognition, it's the learning about learning, essentially, improving. Question is, can we let our agents improve? Can they get better over time by us telling them to behave in a specific way? That'd be kind of cool, right? And it is possible to some extent. For it, you need some kind of recall. Memory could be a simple thread. Probably needs more. You can use function tools, MCPs as well, to save information and get information. Scratchpad is a classic. You create a function or a tool that lets the agent just scribble down what it needs to do. So it can keep a task list, for example. It's a very good way to say, if this is a complex task, write down the steps. Plan steps, write it down in the Scratchpad. And then we talked about looping. Then you end, or rather at the end of execution, you can say like, are you done with the tasks in the Scratchpad? If not, you continue until the agent checks everything off in that Scratchpad. It needs to reflect somehow, and how do we do that? Well, most often just by prompting the model, saying, do you feel done? Have you accomplished the task? Do things in this way. Behave in a certain way. And most often it works. LLMs are kind of quirky at times, right? And using this, we can get it to adapt, to store information about, do I want to behave differently the next time I'm run, next loop, next iteration. So this is just a simple tool to store user preferences. Just write it down in a markdown file. Also fetching the user preferences. And what we can do with that in an agent, give the agent access to those tools, of course, but then you're a senior content researcher and editor helping the user gather information. Well, nothing hard there, nothing new. Before outputting research content to the user, make sure to do it according to their preferences. Use search tools to retrieve content, nothing new there. Update user preferences when needed. So, given that you're running a sufficiently smart base model here, you can say, you're being too wordy, or I don't like the letter K, write everything without it. Then it will go understand that, hopefully, go off and use the user preference functions. So then update accordingly. You ask it to write something new, it will check the preferences, and then you give it feedback. And the more preferences you save, the more it will act according to how you like it. That's a fair way of learning, right? So evolution, learning from reflection. The good question is, what's the best way to bring that on to the next generation of agents, or the next run, next iteration? Basically, it's modifying the system prompt instructions. You saw the instructions before. That's the system prompt. You can send in loads more, of course. So you can choose to modify that if you like. Modify the context, which is not really the system prompt, but more of the information that you can send in. You can add whatever you want into what you're sending into the agent in that thread or as a prompt, right? Using tools and functions, asking it just like the preference example there, to reach out to something, get information, and behave accordingly. This is kind of hard. If you're going to try this in production, be very careful. Some models are models behave differently, let's put it like that. Some might just overwrite the preferences, for example. The example you saw before. Some of the older models, they didn't read, they just wrote all the time. So it acted like this, and you just scratched the entire file and wrote that. That was all. So be mindful. Workflow. This is new. Very cool, actually. It's a good way to get loops going. If you want to have an agent running, working on a task until it's done. You can have gates, checkpoints, etc. You can have the nodes in the workflow can be agents, other integrations to other tools, etc. Or human interaction. You have one specific function that says, like, wait for human interaction to either get approved or denied. You can wire it up accordingly. Its workflow is executors and edges. Executors are the processing units, edges combines them. And also sends events, but it's just mostly used events for observability. And then you combine executors and edges to a graph of some kind. Also, I promised in my excerpt to talk about models. Different models are different people, I usually say. It's they all act differently. Everyone might not have access to all the models. If you're looking at logic and you're writing agents that needs to be smart and clever, GPT-5 performs really well. Grok 4 performs really well in all the tests. Maybe it's not GPT-5 level when you write agents with it, although it kind of aces GPT-5 in tests, which is weird. Gemini from Google, also very good. Nice, competent model. These are all quite large models. Take some time to run stuff in them at times, but can be worth it. But when you're writing agents, most of the heavy lifting is actually done in tools. We're getting or putting stuff for saving or fetching. So how good your agentic system will be is actually determined by how good the tool calling is. toast is done. And different models are, of course, different good at tool calling. And the Anthropic models is actually the best right now at tool calling, it seems. Even though it's not acing in the tests, they perform really well in agentic systems. Google's models, Gemini, as I talked about before, Flash is one of the smaller ones, really fast, but still really good at tool calling. Then Grok and actually OpenAI's models are kind of not the best. You see down here, which is a shame. And also there's leaderboards for everything. And you can look at the leaderboards and you think that this model is supposed to be better than it actually is. Well, yes, that happens quite a lot. I think when you're writing these kinds of systems, after a while it gets to be, it's very much fingerspitzengefühl. You get feeling for what models are best at certain things. But it's also okay to mix models in your systems. So it's good to know. Cost is sadly a factor. Maybe not for you, but your boss probably thinks so. Microsoft didn't even mention Microsoft models here, but they have a series called the Phi series, which are smaller models. There's one more general and a couple of ones that are specific to certain tasks, and they're really good. They are fast and they're very cost efficient. They have one, for example, for translations that ranks as one of the best translating models in the world right now for like 26 different languages. And it's still way, way faster and way, way cheaper than anything else. Google Gemini and the other Google models are nicely priced as well. After that comes AI models, Elon's company, with their Grok series. OpenAI is also quite cheap. It's really cheap now. GPT-5 was very competitively priced when it was released. So it's a very good model. And then at the bottom of the price scale, you have Anthropic's model, Claude, Sonnet, and IQ and those. So super good at tool calling, super good at training your wallet also. It's a factor of 10 at least here. Sometimes a factor of 100 between OpenAI and Anthropic models. So they're really expensive. Check out the leaderboard. You have all manner of cool benchmarks there. It's always nice to see when they drop new models and follow the leaderboards. But then there's the thing, what do we have available in Azure Foundry? Because most of us are .NET developers, and I assume based on Azure. Good thing is, all the OpenAI models almost are there. And they're really, really, really competent. We can't complain. They're nicely priced as well. So you can always build good systems on the OpenAI models, unless you have like super much tool calling. We also have access to the XAI models in Foundry, which is nice. They started some collab a couple of months ago. Of course, Microsoft's own Phi series that I mentioned. Then we have Le French, Mistral, which is good. Don't see many European models around. DeepSeek, and that's Chinese, you say. Yes, but it's open source. So they took a version, and they actually have two versions of DeepSeek. One that they did some post-training on to reduce some of the blockers. You couldn't ask for certain things at the beginning in DeepSeek, but now you actually can if you're running it in Microsoft. Cohere and Flux. Anyone heard of Nano Banana? A few, yeah. Super good at editing images. We don't have that as it's a Google model in Azure Foundry, but we have Flux. Flux have a couple of variants. One for just creating images, and they have one where you can send in an image and ask it to modify it as well, just as Nano Banana. I'd say it's not like nano banana level, but it's very, very good. And hard thing is about writing agent-based systems is, I mentioned memory before. Just as humans, if you create in any way, shape, or form a larger system, you're going to need both short-term and long-term memory to be able to discern what's important. This is not like a super easy and solved problem in the business. There are a couple of services for it that's not Azure-based, but others like startup-based. Do know it's hard. Here be dragons. This is where you're going to do some work. And tool calling. In the beginning, when writing agentic systems, you have a tendency to chuck your entire toolbox in here. Just give it tools. It can do everything. Right, more. But that ends up filling the context. Because all those descriptions and strings, whatnot, goes into the call every time, filling up your context, which creates tooling confusion. So this is also hard part. And then also just coercing the model to use the tools, because just sending in the tool with the description, which you think, of course, is like spot on, doesn't mean the model thinks it's spot on, and doesn't mean the model is going to use it. Which means that you sometimes have to bend its arm a bit, telling it, just injecting stuff into memory, into the system prompt. You have a tool, use it in this way, give an example, etc. All those prompting tricks we've seen. Sometimes you have to do those yourself by code to get it to use the proper functions, tooling. And also models. Models are different, but you can mix and match. You can build workflows where you have different agents doing different parts, where different agents are based on different models and they're good at different things. Diversity is good. And don't take it from me, take it from this guy. When you have systems up and running and working, and there's a new model coming out, it's super good at all the lead boards, everyone's talking about it, and your boss comes and tells you, you changed to the latest model. You say, one does not simply just change the model, because all the fine-tuning that you have done before, the new model is not going to react to it exactly in the same way. So keep that in mind. And with that, I think I've got like 50 seconds left. Connect on LinkedIn. I'm willing to talk about AI agents anytime. This is the repository. Now, you saw snippets of code. It's actually running examples and demos. So if you download this repository, you have the slide or slides and the code, example, everything in that repository. You can run it, test it. And I think that's all from me, right? Yeah. Thank you. Thank you. I'll be in the speaker's corner if you want to continue the agentic discussion. Have a nice continued Øredev.